accuracy is how close to the true value an experimental value is. So for example, in an experiment to find a value for g, if one group gets a value of 9.7 metres per second squared from their experiment and a second group gets 9.4 metres per second squared, the first group's value is more accurate. Having more significant figures can also take you closer to the true value. So for example, 9.73 metres per second squared is taken to be a more accurate value for g than 9.7 metres per second squared. When we are choosing a measuring instrument, we choose the instrument that will give us the most accurate measurement. The balance on the left is giving a more accurate measurement than the balance on the right. There are a few very common exam questions relating to particular examples of increasing accuracy. It's a good idea to flag these up to your students and repeat them often. For 2 marks, when asked how to make accurate measurements of diameter, for example of a wire or a ball bearing, students should write, they will measure several times along or round the thing and average, and secondly, they will use a micrometer or calipers. For 1 mark, when measuring an angle, students should write that they will get a more accurate value by measuring the sides of a large triangle formed from the angle and using trigonometry to calculate the angle, than they will using a protractor. This will give them a value of 2 or 3 decimal places, whereas a protractor gives at most 1 decimal place if you interpolate. So the trig method will always have more significant figures than the protractor method. Another classic for 1 mark is increasing the accuracy of a value by measuring multiples of it and dividing. The most common examples are measuring the width of multiple fringes in an interference pattern and measuring the time for multiple oscillations of something in simple harmonic motion. But it applies to any measurement where there are identical multiples of the thing you are trying to measure. So for example, when you have a bag of identical ball bearings, you measure the mass of lots of them and divide to get a more accurate value for the mass of 1 ball bearing. Remember that this is because it gives you more significant figures than measuring 1 on its own would. And then there are 2 slightly less obvious ones. Generally speaking, you would opt for a digital multimeter over an analogue one, as it would give you a more accurate measurement, as it gives you more significant figures. However, sometimes the reading is not steady. Any significant figures that are flickering are not certain, and also it makes it very difficult to decide what to record. So in this case, where the digital reading is flickering, students should instead write that they would use an analogue meter, as this is easier to read and the extra significant figures on the digital meter are of no use anyway. And finally, when a measuring instrument has 2 scales on it with different sized graduations, students should always write that they would use the scale with smaller graduations, even if that scale has a non-SI unit on it. This is because it gets you closer to the true value and you can then convert to SI units afterwards. So here, if we imagine the purple arrow is the position of the needle, using the PSI scale on the inside gives you 100 PSI with 3 significant figures, that's without interpolating. And then when you convert that to kilopascal, you still have 3 significant figures. While if you used the kilopascal scale to start with, you would have a value with only 2 significant figures without interpolating. Notice that the choice of the more accurate scale here also gives you a lower absolute uncertainty for the measurement. If you're finding these videos useful, please subscribe and don't forget to check out our resources on the website and follow Learning Dojo on Twitter.